Sorry.
And it started in 2019 and finishes in 2023. And so we have a nice chunk of money to try and encourage pollinators across the North Sea region. And it's half funded by the European Regional Development Fund through the Interreg programme. So we have 18 partners from 7 countries, which is all of the North Sea region countries. And the Game and Wildlife Conservation Trust is the lead partner. So why the Bespoke project? Well, we know that pollination is important for many crops, and it's been estimated that that's worth 15 billion across the EU. But we also know that pollinators are in decline, and as a consequence, the levels of pollination are not always optimal across the whole of the EU, and particularly in the North Sea region, which you can see. So the areas with poor or low pollination are indicated by the red, and then the better it gets, the more blue the color from this paper. And this was based on land use and potential to support pollinators, and also the flight ranges of the pollinators. And also the European Court of Auditors published a report in 2020, and this highlighted that the EU had failed to protect bees and pollinators for various reasons. And so we do need more work to try and encourage them across the region. So what types of pollinators are we interested in? Well, of course, there's honeybees, which most people know, but of course, there's a whole group of wild pollinators, which are considered more important in pollination in many cases. So bumblebees, solitary bees, hoverflies, and some other, and some flies as well. And also butterflies and moths could play a role. But many of these pollinators are in decline, and there's evidence for that. And so it is of quite a concern that, like all insects, we are losing them. So why pollination? Well, pollination can increase the yield and the quality of many crops, particularly the fruit crops. And you can see here this apple. This apple here has received good pollination. You can see it's got more seeds and a bigger fruit. And that applies to a lot of these different fruit crops, so that they are dependent, highly dependent on insect pollination. And then there are some crops which we consider as being moderately dependent. So sunflowers, field beans, broad beans, also is evidence that they are moderately dependent, but in the Bespoke project, we're not always finding that. In fact, it seems to be low dependency. And then crops like oilseed rape, which are predominantly wind pollinated, but have some insect pollination. But there are quite a few knowledge gaps despite all the work that's gone on so far. So we know that, for example, there's quite a lot of variation between cultivars in pollination dependency, particularly with oilseed rape and beans. And so that's something we need to better understand. So if you're a grower farmer in an area with poor floral resources, you might not be wanting to plant a cultivar that is really heavily dependent on insect pollination. Or you may want to do something about it and increase the insects in your area through provision of wildflower habitats. We understand something about the impact of pollination for many crops on the yield and quality, but I think there's more to be understood. But also that understanding of how much financial efforts involved in creating and boosting pollinator numbers, and will that pay back in terms of increased crop yield and quality? And linked to that is finding the most efficient way to encourage pollinators. Should it be by planting wildflower areas, or should we be thinking about other floral-rich resources in the landscape, such as grassland, which can be diversified with flowers, and hedgerows? Both of these are been identified as really important in the landscape in terms of supporting pollinators, but also woodland and other habitats. Weeds and crops as well is something we're going to look at. Also, the relative importance of each of the different pollinator types, we need to understand that as well, because pollination is complicated. It's not just the numbers of visits, but also how effective those pollinators are. And then we have the sources of wild pollinators. So are they coming from a local area, for example, the adjacent field margin, or is it the wider landscape that's more important? And there's some research on that already. So if you look, for example, at apple, which is probably one of the most well-studied crops worldwide in terms of pollination, you can see that There's this was a review paper that looked at a whole range of different studies, and they found that, yeah, these different types of bees were generally present in apple orchards. So andrenid bees were some of the most abundant, and honeybees. But when we look at the visitation rate, you can see that actually andrenids are quite low compared to the bumblebees. And actually the numbers of flowers visited per minute is really much higher for bumblebees. So it's all indicating that bumblebees are actually the better pollinator. And likewise, in terms of stigma contact, you can see that both of them are very good, but honeybees are poorer. So you have to take all of this into consideration when thinking about which are the best pollinators for a crop. So in the Bespoke project, we're looking at a whole range of different things. So we have elements of research, modeling, policy, and outreach, and of also a communication program and a monitoring evaluation going on alongside that. So in the first instance, we were really interested in developing more targeted seed mixes. So can we develop seed mixes which support the types of pollinators needed by each crop type? Something like this hasn't really been tried before. And then we're also looking at other novel crops that are coming along and what they might provide, and also the wider benefits of flowers for a range of different insects, and also looking at grassland as well, and flower-rich grassland. We're also evaluating some of the techniques for measuring pollination to see if they can be part of routine practice. So can a farmer go out there and measure his levels of pollination using a simple technique and get an idea of whether it's likely to be adequate or not? We're making good progress with that with the fruit crops, but for field beans, it's proving a bit more challenging. And then we've got a range of modeling, and you'll hear about that in the first talk this afternoon. So first of all, trying to identify regions that need improving, and then trying to take that a bit further and identify the flower area needed. And we've also got a new program of work which will look at seed mixes and how you might have a tool that can help select the right sort of seed mix. Then we're also looking at policy as well. Because of that auditor's report, we've been reviewing lots of the different environmental packages in each of the North Sea region countries and seeing if they're adequate or not and how they might be improved to help inform policy. And then we're also looking at some of the barriers with the farmers and growers, really what's stopping them from putting these habitats in place, what are the barriers, and what might be the economic gains of enhancing pollinators. And so we also have lots of outputs. We've got some already. So we've got various guides out at the moment, which are freely available from our website. So please have a look at those. So there's one on wildflowers. So that links in with Jojanneke's talk later this afternoon. We've got some guides on the various types of bumblebees. So a general guide for different, identifying some of the key groups of pollinators. Then some more specific ones, for example, on the common bumblebees, and then the new ones coming out soon on solitary bees, which is a bit more comprehensive. Some of these have been translated into other languages, not just English. And then we've got a broader booklet that looks at a whole range of different habitats and what they may support, not just in terms of insects, but other biodiversity. We also have a newsletter, so do please sign up for our newsletter. So thank you very much. So that's the end of the introduction. So I'll just stop my share. So our first speaker is Meeus from the University of Ghent. So he's going to be talking about some of the modelling work that he's been doing as part of the project.
And just one thing in between, there are already some questions. I will collect them and we will do that later on in the meeting.
Hello, everybody's seeing my screen probably. I will slide this aside, it doesn't bother me.
Yep.
Okay, I will be talking to you about the pollination model that we are presenting within the BEESPOKE and the tool that we have that you can use to see what the pollination services are for your crop of interest. Most of the work that I will be presenting is actually work which is also done by Daniel Ariza. I will actually also make a pointer here. Okay. Yeah. So the things that I will be talking about, so shortly I will talk about pollination of wild bees and mainly in the context of cherries. I will explain to you why landscape elements are so important for bees being present in the landscape. Then I will go to the modeling part and I will explain to you how our model works. So there is some mathematics there, so be careful there, but we will try to make it as interesting as possible. When we go to the tool on itself is very, very easy and a lot of things in it happen black box. So I want to explain to you some of the things which are happening underneath the hood of the tool, that you can also see what the limitations are of the tool and see how interesting the tool actually is. And then finally, I will talk about some next steps and what is to be expected next. So, okay, to start, I think this is a very well-known paper and most of you will probably already know it. It was an eye-opener in the sense that wild bees are very important in terms of pollinating a lot of different crops, and that the pollination performance of these wild bees was often outcompeting the pollination performance of honeybees. So in the map there, you see the different parts of the world where there is data for. We have data there was data on honeybees and on wild bees, and this meta-analysis then indeed showed. And here you see the gradient of for different crops, how well that a certain pollinator actually pollinates the crop of interest. And then you see that the gradient is often much better for wild insects than you look than when you look for honeybees. So this was an eye-opener in the sense that when you want to perform a good pollination, you have to think about the bees which are in your environment and how you can attract these bees to help you in your pollination services. We specifically in our lab looked for this relation for cherry trees, and where we found actually indeed the same conclusion. When you have a high abundance of a single bee species, you get a better pollination performance, you get more cherries when you have a high diversity of different species flying around there. And the main thing that we saw is that the diversity of bees that you then want to get into these kind of here fruit orchards, that this is highly dependent on the environment that your fruit orchard is in. So quickly, some data on those two things. So we visited different orchards where we looked at the probability of the fruit set. So you had a fruit or you had no fruit if you counted the amount of flowers on a certain tree branch. And then you actually saw that there was a positive relation with pollinator diversity. So the number of different pollinators present inside the bee orchard. This number was actually correlated also with wild pollinator abundance. So if we had a higher richness of pollinators, we also had a higher abundance of different pollinators in there. And in both cases, we saw a positive relation with more fruit set with species richness and with pollinator abundance. We did not see this correlation when we only counted the amount of honeybees which were present, so no correlation was found with higher fruit set in that case. In those same environments, we also looked at the different habitats around the fruit orchard. And then we actually saw that the amount of wild pollinators showed a positive relation with the amount of semi-natural habitat very close to the orchard. So 100 meters around the orchard, there was a very nice relation, seeing higher biodiversity if the percentage of semi-natural habitat was higher. Another relation that we saw was the percentage of herb cover and flowering herb cover in the orchard itself. When that one was higher, we also noticed more or a higher diversity and more wild bees on the crop of interest, in our case, the cherry trees. So these observations, and together with observations based in literature, can made us draw two kind of conclusions. One is that biodiversity results in a good pollination of a lot of crops. Bee biodiversity here also often being linked with wild bee abundance. Where you have a high bee diversity, often you also have a high wild bee abundance. And the second conclusion, that to get this kind of high biodiversity, but there is a nice relation with semi-natural habitats being around this fruit orchard. So, okay, if we want to translate this into a model, there are some things that we need to think about. The first thing about the bee diversity is, okay, is it just bee diversity that you indeed want there, or are there indeed different bees needed for different kind of crops? That's the first question that you need to think about. And the second thing, and this is then maybe the most important question, is, okay, how can you quantify this? So how can you link these habitats which are around the orchards? How can you link this to indeed say to estimate a certain pollination service these bees provide? And I will now mainly talk about this second question, and later on I will go to this first question. So we bring these two questions together. So these are the main questions that we have, and we say, like, from this main question, we want to make a tool that the user doesn't need to find these things out himself, that in the tool an answer can be provided on these two questions, and a pollination service can be estimated based on the bees of interest in this specific environment that you want it to work. Okay, the first thing, we started from a model which already existed. So we didn't reinvent the maths here. So we started from a model already described in 2009. And what we mainly do in BEESPOKE is actually getting the mathematics behind this, putting it in a tool, so you can use it and you don't have to do all the mathematics yourself. So all these mathematics you will not see in the model when you use a tool. This will all be blind and you will not see it. But I think it's important that you know what is going on there. So I will try to explain the different steps which are done automatically inside the tool. So the main thing that the tool does, you go to a specific place in a certain landscape, and from that landscape we will estimate a specific pollination potential there, a specific pollination service. So the first thing that we need to do when we get the landscape, we translate this in land covers, and these land covers we put to a raster, so we make all small squares of them, and for each land cover we give a scoring how well a bee can nest in that specific land cover. So that's the first thing that we do. We translate these land cover maps into scoring maps of nesting suitability. So that's the first map that we create. A second map that we create is in those same rasters, we give a certain scoring for the flower suitability, so how much food can a specific bee find in that specific place. So these kind of maps need to be made for a specific bee. From the moment you have these maps, you can actually start to estimate a relative abundance that a certain bee will be nesting in a certain place. So what do you need? You need indeed the likelihood that the bee will be nesting there, and then the amount of food it can find when he leaves his specific nest, or she leaves his specific nest. So, of course, it will find more resources close to the nest than it will find resources far away from the nest. So, but these two parameters together give us a certain relative bee abundance at a specific place. So this is the first calculations that will be done. These will be done for different kind of bees. So we can have, for instance, another bee which has a higher foraging range. It will be able to collect then more resources from further away, and you will probably or you will get another bee abundance at a specific parcel in your point. So to get these kind of maps, the thing that we need to do is actually an iteration process, and we need to calculate these kind of things for all the different raster points, so we get the relative abundance at the different nesting parcels of a specific bee. So that's the first layer that we will have. From the moment you have such kind of map, you can start to calculate, okay, now how many bees do I expect that will visit my crop? So this map we have calculated. Then you say, for instance, here is at this parcel, I'm interested to know how many bees will be able to visit my crop. So then again, we will look at how many bees, we will look at the foraging distance of the bee which is able to visit the crop. A bee which is not interested in the crop, for that one, the model will not be calculated. But for a bee which is interested in your crop, we will again look at the foraging distance that that bee has. And the closer the bee nests to your crop and is able to get good nests close to your crop, the more bees will likely visit your crop. So that's actually the next step in the model. And this we then do for the different kind of bees which are able to indeed visit your crop. And from these different estimations, we make the weight average, and this will be the final pollination service estimated for your crop of interest. So this is basically just a small summary. So we start from a land cover map. From that land cover map, we make a nesting suitability map. We make a floral suitability map. And from there on, we actually estimate for a specific point what the pollination services could be for one specific bee. We do this, for instance, for one bee, for instance, for a mason bee, but we can do this for different kind of bees, and you will get different kind of estimations for different kind of bees, and we can then take the average of this. So, okay, this is the first link that we said, okay, it's important to link habitat to which kind of bee abundance that you could expect in a specific region. That's the first part that we wanted to solve. But now we still need to see, okay, for which bees are we going to perform this model? Are we going to perform it for all the bees? For which bees will we do this for your crop of interest? So again, this is something that the tool automatically does for you, but I will show you how we do it. So you need to fill in your coordinates, which means that we will know your country. And you need to select a crop of interest, which you need to fill in here. And so we know, okay, for which pollinators do we need to filter in terms of the crop of interest. So if we look at the tool, the first thing that the tool will now do is rank the different pollinators in your country and for your crop, which are important to do the estimations for. And then we'll do the estimations. This one I explained. Now I'm going to explain how do we rank these pollinators in terms of country and crop. For this, we use the database, the crop pollinator database. So for this database, and it's still expanding, there are 3,000 fields of data points in 190 study systems. So we have data for the different countries inside the North Sea region, and these are the different crops for which we found data. It is not that we find data for each country, and that's actually the first filtering step that we do in the database. From the moment that you select a country and a crop, okay, which data do we have to select the bees? And I give here an example. For instance, for if you would select the country Belgium, then we have data from Belgium for sweet cherry, and we have also for rapeseed data for Belgium. But if you, for instance, select the country UK, we don't have sweet cherry data from the UK in here, and we only have data from Belgium. So we then select pollinators from Belgium for data for the UK. We will see later on how we handle this and how we still think that we are making correct predictions. Because by filtering this data, there are actually two kind of problems that we face. The first thing, for instance, when you have a country and you have data for that country, that's the best case, you have very good data. For instance, for Belgium and sweet cherry, we now have something like 40 bee species who visit sweet cherries in Belgium, meaning that we would need to model 40 bee species, which is a lot, and the computing power, it's way too difficult to do this. Also, you need to do the estimations for those 40 different bee species, and not for all these 40 different bee species. You can do these estimations. In total, there are up to something like 2,000 bees in Europe. So in theory, it could be that in the end, we need to be modeling 2,000 bee species, which would also be a lot. So we need to find a solution for this. The second thing that we need to find a solution for is indeed the thing that I explained, that for instance, sometimes we have a country, but we don't have data specifically for that country. So we have then data from other countries. And how are we gonna match this data, that this data is still realistically? So for those two problems, we actually have the same solution. And the solution is that we actually do not model real bees, we're gonna model virtual bees. And I will explain you what I mean with this, and I will explain it with the example from with the Belgian data. So country Belgium, sweet cherry data also from Belgium. If we look at this data and we summarize this data, it was something around 40 bees of data that we have. We group them in terms of how important are these bees, in terms of how many observations of a pollinator is there in the amount of total observations there. And then you get a kind of estimation of, or a calculation of how much you see a bee in a specific orchard. So this could be kind of an importance of that bee to visit the crop, and could be, and this importance we could use to do the weighing of the different models for the different bees. But okay, these are 40 bees. We translate this in 7 virtual bees. So we are not going to do the calculation for all 40 bees, but we will actually look at the threads of the bees, and we will look at the threads of these bees based on the data we have from the European database of Stuart Roberts. And we will group all these bees then in different kind of categories. Is it a bumblebee? And is it a bumblebee, for instance, which is nesting above the ground? Is it a bumblebee which is nesting below the ground? Here, is it a solitary bee, which is a digger bee? And what is the foraging range of this kind of bee? So we have in total something like, we have 7 categories, which we're gonna group these different kind of bees, which then visits a certain crop. So if we would do this for the data of sweet cherry in Belgium, we get this kind of division. So the most of them are visited by a digger bee with an average kind of foraging distance. What you also see here is this warning, 35% of the bees which are present here, or the observation power of 35% of bees, we do not have the data to categorize them in one of these categories. This could be because we have completely no information about this foraging distance, or the estimated foraging distance is really different from the categories that we have made. In that sense, we can maybe make more categories. Or for instance, it is a parasitic bee, and for parasitic bees, it's very difficult for us to determine their nesting preferences, because it's then the nesting preferences of the bee that they parasitize on, and that can then be often bees which nest in different kind of places. So that's something very difficult to do. So these are then categorized in the warning category, and I will come to you later how we deal with this. Or no, it's now. So if you look now for the data that we have and how well that we can categorize all the bees and actually make a kind of good prediction of the bees, we have actually two crops for which we cannot make good predictions. So we have the raspberries and the buckwheat, for which here 65 and here 75% of the bees fall into the warning category, meaning like, okay, we only can model for, in that case, only for 25% of the bees. So we can say like, okay, the modeling that we do, is it still worth mentioning? So in that sense, we probably will not do the modeling for the raspberry and the buckwheat. And for the numbers which are in yellow, we will probably give a warning that the user knows that you have, for instance, for sweet cherry, that you have a kind of modeling of 65% of the bees are modeled. And for the other ones, we will probably use no warning and say like, okay, we have enough percentage to say that we can perform a good modeling. Okay, so this is what is happening underneath the hood of the model. Now, just quickly, we can quickly go through what you actually will see when you open the application. So, and I already explained this. So you fill in the GPS coordinates of your field of interest. You say how big it is, and you say which kind of crop that you use. Now, in this case, red clover is standing here. When you push on the button find, it will go to the GPS locations that you have filled in. When you click on habitats, it will actually show you the Corine land use data, and it will give the different categories of the Corine land use data, meaning like on which kind of data are we doing the modeling to do a prediction of the bees present in that specific place. If you then press calculate, it will calculate the final output of the model, meaning you will not see for which bees he does it, so he automatically groups the different bees and will give the final output to make the tool as simple as possible. So for instance, if you would do this for red clover, you will actually get the estimated pollination services, so the relative pollination service, and you will get it as an overlay on your field. But what we do is that we put this overlay as a circle over your field. So it will not have the exact the same size as your field, because we only have the coordinates, but it will overlay it as a circle. And you will actually also be able to see where are the highest and the lowest pollination potential in your field. I will go in the next slide. I will explain these numbers a little bit better, that you can also get an idea what those numbers actually mean. But here is the example of red clover. If you, for instance, would do the same thing for sweet cherry, you indeed see that the pollination potential is here different distributed over your field. And you also see that the relative pollination services are really, really different in terms of numbers. If you go to those numbers, what do they mean and how do you need to look at it to actually say like, okay, do I have a good field or do I have a bad field? So this is extra information that we will provide. We will give an idea what your scoring means in terms of the scoring in the rest of your country. One in absolute values. For instance, in this case, your value is something like 0.07. What does this mean in the minimum and the maximum of the whole country? So in this case, it is located kind of low. But okay, so this is the first kind of information. So this gives you an idea how much this number can actually rise. But okay, it could be, because you don't know the distribution of the 0 to the 0.8, it could be that 90% of the people have a very, very low number. So this is also the information that we will give, how many percent of land cover has a better score than you. So you then know indeed how well you are situated of the rest of the country and how much you can actually improve. Having this data for whole the country is on itself interesting, but you have to realize that most people want to know this for agricultural areas. We already know that agricultural areas often score less, especially if you would relate it to natural areas. So we will also make the same prediction if you only look at agricultural landscapes, which are way more interesting for you to compare, to see like, is my field actually, if you look at all the other fields in the country, is it actually located in a good environment? So these are the first main information that we will provide. Then these options are now already available. They are indeed, if you saw the previous in the previous slides, there was a link to the web tool. We have some problems with the amount of data of putting everything online, so it's not yet online for all the countries of the North Sea region, but it's already working for some. But it will be in the next week. It will be online for all the countries. Then, what are the next things that we will add to the tool? The next is how that a flower strip can provide an added value for your crop. When you think about adding a flower strip for your crop, there are actually, or when you think about flower strips in agriculture, there are actually about two things you need to consider. One is, am I providing extra flowers in terms of the pollination service? Do I want a better pollination of my crop? Is that the goal that I'm after? Or the goal could also be, am I thinking about biodiversity conservation on itself? So these are actually two different things, and we need to be aware of this, that these things are not per se the same. One good argument here is that what we often see is that the main species which are threatened, the main red list species, are often not found in farmland. And also the crop pollinators, the one that you saw in my presentation before as the ones which are the most important to attract to your crop, are often the most widespread and abundant species, and are indeed most often not species which are red list species. So these are two different things. So okay, the added value of a flower strip, when you calculate this, the blue thing is the crop of interest, the green circle around it is the landscape on the small scale. If you then want to know the effect of the flower field, you actually need to think about the wider area again, which is around your flower strip. Because you cannot just say like, oh, I have a flower strip and this is the added value of the flower strip. The added value of your flower strip depends on the actual landscape which is surrounding that flower strip. And there is some clear data on this when they looked at the effect of a flower strip, how much biodiversity of how many bees a flower strip attracted, and especially then in species richness, especially in biodiversity, they saw different effects depending on where the flower strip is located. And then they talk about cleared, simple, and complex landscapes. And I don't know by heart the exact cutoffs in percentages, but the cleared landscape is a landscape with very, very few semi-natural elements. A complex landscape has a lot of semi-natural elements, and a simple landscape is somewhere in between. And if you then look, then you see that in cleared landscapes, the added value of a flower strip is way lower than in simple landscapes. And again, in complex landscapes, the added value of a flower strip is again lower. And I always explain this by the very simple comparison that when you, for instance, place a flower strip in a desert, it is kind of normal that you will not attract any bees because you are in a desert. When you are when you place a flower strip in a very natural habitat, you will also not increase the effect of the flower strip because actually the bees have what they want there, and you will not see higher biodiversity because of your flower strip. So these are then the two extremes. And it is mainly indeed in agricultural landscape, in diversified agricultural landscapes where there are still natural habitats present, that you actually can start to work with these kind of flower strips to attract pollinators and to attract them to your crop. So this is a little bit the context. So again, this context is built into the model because the model can actually work with these kind of landscape effects. So the added value of a strip with the tool that we have actually calculates these kind of effects of the surrounding landscape. That's why I explained them to you. Just some thoughts that I have on this in terms of when you are adding a flower strip more to a cleared landscape. So in a landscape where there are very, very few natural elements, it has few added value. I think when you are in this case, it's kind of important that actually landscapes improvements on the bigger scale are actually needed before actually a farmer starts to plant flowers to attract bees to himself. And when you are doing this, I think this is more than you are more interested in pollination services, and these kind of alterations should be more sector driven and not really be driven by, I think, funding mechanisms. The other thing is true, I think, when you are in very complex landscapes. When you are in very complex landscapes, you already have a lot of pollinators in your environment. When you have a crop indeed very close to these kind of environments, your flower strips will have, in terms of pollination services for your crop, have fewer added value, but you can have a big added value in terms of conservation, because there are a lot of more rare bees probably already in your environment, so you can indeed start to support them better. So in that sense, I think funding mechanisms can be more from the EU or organizations like this. I think the simple landscapes, here it is very important to see which kind of flowers you will plant. And here you can indeed more think about, do I really want plants which attract the pollinators, which are important for my crop? Or do I go for plants where I say like, okay, these are very important for biodiversity conservation goals. So this is a general thing. Now, if we go to the tool, this is a part of the tool which is currently not yet ready, but will be ready in a few months, because we actually basically use the same kind of calculations and we only need to work on the outline of the tool or how it looks. So the first step is the same, that you have your normal prediction of pollination services. In your second tab, you can then actually add a flower strip, which is then to the different land covers which is present. And the flower strip that you add, you can give it a flower quality, meaning something from 0 to 1, that you say like, okay, this is something where a lot of flowers are present. But with that landscape, you can also play with a nesting quality, because indeed in some places it could be more important to improve the nesting quality. So this is also something that you can add to the tool to see how much the pollination potential actually will improve when you add a specific flower strip or nesting quality in the landscape. And these were the things that I wanted to tell you. I want to repeat again that a lot of what I presented is work of Daniel. And I don't know if there are questions that are asked at the end or now, but that was it for me.
Maybe we can do 2 or 3 questions, because we're a little bit short of time, but I saw Michelle, you had a question about parasitic bees.
Yeah, actually, as I'm on the project, I'm happy to give my question up for someone else if there's another question from the audience.
Now, maybe it's good to make clear that we're talking about wild bees, so not honeybees. There were some questions about that.
While you're looking at the other questions, and my question was really about, do we need to worry about including parasitic bees in the data anyway, as they're not really considered important pollinators compared to our andrenids and bumblebees and things?
No, yeah, you are indeed right. We could indeed, from the moment that they are parasitic bees, we could indeed say like we do not count those as a bee which is pollinating, and then we will increase those percentages. That's indeed true.
And then I'm not sure about the rest of the North Sea region. Maybe other people can contribute here, but a lot of our cherry and soft fruit crops are grown under tunnel, and I think that can change the communities of pollinators that visit the flowers. So it might be quite good to divide out those two main crop types.
Yeah, the thing is, for now that's indeed not included, but from the moment we have data on it, we can very easily do it. But yeah, you need always to have data to be able to make those kind of decisions. So if there are people who say like, oh yes, we have data, or we have good data sets, and they can help in these kind of choices, we are very happy with these kind of things, and that we can indeed improve our selection, because indeed the selection is now based on a data set, and yeah, a data set is never perfect.
Are there any questions from? Sorry, I'm going to be very UK centric here. I can see there's some agronomists from UK fruits production. There's Janet and James. I wonder if this is something that you would use with your growers to try and maybe improve agri-environmental schemes. So that's James Shillito and Janet Allen.
Can you hear me?
Yep.
Yep. Right. Okay. Yeah, probably. Yes. I think it would be particularly useful for sites where there isn't perhaps the diversification of other fruit crops present. And there are growers who have sort of specialized in cherry growing, and the other crops that they may have around are, either general arable crops or vegetables or something like that, and possibly some soft fruit like strawberries. So in that situation, yeah, I think it could be interesting. It could be useful.
Yeah, Michelle, I've just been trying to Google the tool and I couldn't find it. So maybe an access point could be made more easily findable.
Yeah, so for now we did not yet advertise it. So I think indeed by Googling it, you will not find it. But
Okay.
Now we will indeed start to advertise it on the sites, and then you will get keywords there. But I have provided the direct link in the presentation, so that should already work.
Ivan, will it be available on the bespoke-NSR website, where all the other information is?
So we will put links there on there, but this is something I need to discuss with Jan Willem, how we best do this. But for now, there is a link which works on our servers. But yeah, we need to make the link to the general bespoke.
Yeah, no problem. We can make the link, but also the presentations will be downloadable from the website. So
Yeah. Can I make another comment? Actually, I think the service might be particularly useful for people, well, growers of black currants who are very reliant, because of when their crop flowers, on natural pollinators, particularly bumblebees, and to be able to have an idea of what the potential is for natural pollination could be really useful for them, because they've got insects which are going to be flying and pollinating under, conditions when honeybees wouldn't necessarily want to be out there. So just a thought I've just had, black currants are a sort of difficult area because they're so early.
Yeah. For now, it's not in there because we don't have data for pollinators, but if you can provide us data of pollinators, it's something we can consider to add. From now on, adding an extra one is not the, well, it's of course again work, but it's not the big work. So it's for sure possible to add extra crops in there.
Yeah, yeah.
I think we've got some UK data on blackcurrant pollinators, about 3 or 4 years worth. And I thought actually, Janet, you made another really good point that I don't know whether is included in the model. So if you have a farmer who's just growing one mass flowering crop and then a lot of arable, but you also have farms that have sort of mass flowering crops that are kind of sequential, so might provide forage, not necessarily nesting habitat, but might provide forage for a lot of the season.
Yeah, no, it's one of the things that we are thinking as an improvement of it, but it's not yet in this version there.
Right. Okay.
Okay, so I think we should go on, otherwise Jojanneke doesn't have any time left for a presentation. So please, Jojanneke, she's from the Cruydt Hoek in Friesland, the Netherlands.
Yes, thank you, Jan Willem. Can you all see my presentation?
Yep.
Good. So this is mainly about the establishment and management of bespoke mixes. What happens? All right, this works. As long as it works. So yes, to be successful with flower strips, you need particular knowledge and be attentive on the management. So these are the topics I would like to discuss with you today, or well, I will give you some information and then hopefully we'll have a discussion. So it will be about sowing and soil preparation, the management of the flower strips. Where can I get my seeds? What machines to use? It's all very practical. And I have some extra questions from our group, a very good input, like why is it so hard to cut and remove the vegetation? Or how do we feel about annual mixes? All things that are rather interesting. I would like to start with you with the best time for sowing. And when we are sowing mixes, I'm thinking about bespoke mixes that consist of perennials mainly and some biennials and perhaps some annuals as well, especially when we apply spring sowing, which often happens. It did in the Netherlands anyway. But best time for sowing in general of perennial mixes would be August, September, October perhaps. Well, a time when the soil is still warm and we have some moist and some cooler nights are coming, which is very good for triggering germination of native seeds. And you can prepare the soil in July, which is very nice because usually you have a very dry period. Second best time for sowing is spring. And usually we sow in April or May. But here again, sometimes it's, well, if it's possible to get onto the land, because it can be very wet still, you would even sometimes like to start in March, which is very early. But again, because of the cool nights, that can favor your germination. But these mixes in general also have lots of seeds that prefer warm temperatures. So sowing in May can be very good. We have been sowing in 2020 in spring, and it was a very hot and dry spring. So germination started somewhere in June in the Netherlands because we didn't have any moist available. Right, so how to prepare the soil? You start early, particularly when you anticipate weeds and grasses, which is of course less suitable for a flower strip occasion, but yes, well, things happen and you have to make choices. So yeah, then it's better to start early and you work on the dry conditions. It's very important not to compact the soil or restore the soil if it's compacted for proper plant growth. All farmers know what plants need to grow properly. Choose a sunny location, dry soil with low fertility. If possible, this is rather hard very often, since arable fields are, well, very suitable for growing crops and thus fertile. But yes, the better the preparation, the more years of successful flower strip you can achieve. So what do we do? Usually we plow and rotor and prepare a seed bed. But after you've prepared the seed bed, and it's all clean, looking clean anyway, you very often would like to leave the seed bed barren for some weeks and see what weeds will come up. Often there's still some remnants of grasses, some grass roots and bits. So you want to harrow it after some weeks and perhaps repeat this, and you can repeat it again. It's best not to fertilize your flower strip unless the soil is so poor that it's completely impossible for plants to grow there properly, or it's too acidic. There could be all sorts of reasons, but usually there's totally no need to use any fertilizers. And then when you have a nice seed bed, you have to sow with dry weather, naturally, I suppose. And you can apply 1 to 4 grams on average per square meter, depending on the seed size and the soil and the time of sowing. Because I would prefer very often to use only 1 gram per square meter. That's a lot of seeds already, particularly with native flower seeds. When sowing in autumn, or like August, September, October. But yes, sometimes you need more seeds, or when it's a very dry spring, perhaps it's useful to use a bit more, but 1 or 2 grams could be plenty. Please do not sow any grasses. I know many of you do, and they can be useful from an ecological point of view. For some birds and also for pollinators, but they can be very aggressive, and usually they are still available in the field from seeds and bits of roots anyway, so they will dominate very quickly, and particularly because the soil can be very fertile, and the grasses can grow much faster than the herbs. So if you really want to sow any grasses, try as little as possible. I know some will sow up to 80 or 90% grasses, and please think why do I want to sow these grasses? Is it because I like a cheap mix? What is the purpose of your mix? I think that's the first question you need to ask. And yeah, often perhaps a mix with lots of grass in. It says you have to sow it 4 grams per square meter, but without the grasses, you don't need so much seed anyway, so could be very helpful to your flower strip. To make it easier to sow, especially by hand, but sometimes also by machine, you can mix the seeds with a filler for a more even spread, with some meal or sand or corn granules. And then if it's about a couple of thousand square meters, you can sow it broadcast by hand. That's fairly easy. But if it's about hectares, it's perhaps more helpful to do it with a machine. And I mentioned some machines here, there's a picture with a sowing machine. And with every machine, the thing you have to remember is that because of the machine is shaking, it will unmix the mix. So you have to consider this and perhaps add a little bit of mix every 100 meters or something, or even more, to keep it from unmixing or get the same seeds everywhere. Sorry. Always sow as deep as the seed size, so not deeper. And this is, some seeds may want to germinate from deeper below, but there's also many that need the light to germinate. So I think this is quite important. And then you can roll the soil to firm the seed to the soil. Would be nice to do this before there's some rain coming. And then about maintenance, very important bit also. Two things you need to remember is that cutting the field, the strip, is very important. And you don't do it too deep. You can do it too high, perhaps, I'm not sure, but please not deeper than 10 to 15 centimeters to also keep the plants that are already there. And second bit is that you remove the cuttings, and this is so very important, but also quite hard sometimes for people to act on this. And you can collect the cuttings within a week. You can do it on the same day, but don't leave them longer than a week or a couple of days, because it will turn to compost on the spot, and that will be very bad for the plants that are growing underneath. I have some notes here on the tools you can use for cutting and removing the cuttings. But if you do it by hand, you can use a brush cutter but with a blade. So you will cut the vegetation and not shred it to bits. You can use a butterfly mower. I know it's not very fashionable anymore for farmers, but this used to be a fantastic tool for cutting, for making hay. And then I heard the rotary mower became very popular because it was diesel was very cheap and it cost a lot more energy to use a rotary mower, but it's also fine because it's cutting the vegetation, so that's good. And you can use a corn shredder, but those are very heavy machines. And leave some bits. You should avoid to leave some bits on the fields, but yeah, it can work. And John told me a nice tip, said some farmers just blow it into the stubble and then cultivate the soil. And that's nice as long as there are no nasty weeds present. So then, yes, in the first year, you have to sort of expect no bloom, especially when you have been sowing in spring. Unless you have added some annuals, then you will see some annuals. And it's possible that you will also find annuals of all sorts of weeds. And this is not really a problem unless these annuals and annual weeds are suffocating the still developing perennials that are on the soil. So at some point, it may be that the soil doesn't get any light anymore, and you would have to start making your first cut to provide more sun for the germinating perennials. With autumn sowing, you can expect more optimal germination and development. So in the first year, you pay attention to aggressive weeds, and perhaps you have to cut a couple of times to keep them in check. If it's not necessary, you can just stay with one cut in later in the late summer, autumn. And if you are find this important, you can take out harmful weeds. Well, I myself would suggest to use a brush cutter with a blade for this, or so at least avoid that they can seed if they are a pain in your field. Some use spot spraying, but yes, I think that's of course also a possibility, which I would not promote so much, but it's very practical, I suppose. And then second year and further, the third and fourth and fifth and sixth and seventh and 10th year and 20th year, you can go on forever if you have a good field. You can still pay attention to harmful weeds and mowing them before they set seed. And every year you have to cut, and you can use different times for cutting, depending on your soil. If you have very productive soil, you may have so much growth that it would be nice to have 1 or 2 cuts extra every year. You can use spring for this, for example. Yes, even people who like to have 3 times for cutting the vegetation. But every time when you cut, it's helpful to leave 15 to 30% standing. You leave standing as much as you like, but the purpose of this is that well, many insects and also beneficial insects like to have some shelter someplace. And also if you leave bits standing and it's still in the season, you would have some bits still in flower. So that could be very helpful to your pollinators as well. So, well, yes, what to do with grasses? Grasses usually come in from bordering areas or are sown with the mix. So like I said, perhaps it's a good idea not to sow any grasses, or very, very little, or not aggressive species anyway, especially on fertile soil. And remove the cuttings. It's really important. So yeah, those are the biggest and most effective ways of preventing grasses from becoming dominant. I've noticed very often that people don't cut their fields until the next year somewhere. You have to remember that all these plants at the bottom on the soil still need light. And when there's no light for a very long time, they will just die sometime. And you want to prevent this. And you also need many of your flowers to be able to seed someplace again in the future. And they also need some space and light for this. So this is why it's very important to cut the strips. And John also suggests, well, you could use Graminocides. I think this is sometimes used. Could be very effective indeed. I have no idea what the effect is on pollinators or the soil biology, but if this is no problem, then this could be a solution. And what I also like is that you could scarify the soil for up to 70%, for example, after a couple of years when it becomes very grassy again. And then in this way, you will also make a lot of soil available for species to germinate again and have some light. There was a question about can we use grazing in a flower strip? Yes and no, I think, because like sheep, for example, which are probably best suitable, they like flowers quite a lot. So if you just put them on the field and they can eat whatever they want, they will go for the flowers, which is not very helpful for your pollinators. But you could use after grazing, or better still, I think, strip grazing. So you only give them a little bit every time and they get hungry and eat everything. And then you give them another bit. I think that works okay. And then there was another tip from John saying, please avoid establishing flower strips at the bottom of slopes where you have runoff accumulating. This is something totally different, but I think it's always good to mind your environment, what's happening in the area, and what is a good site for your flower strip. So, following question, why is it so hard to cut and remove the vegetation? Like here you see in one of our bespoke sites, it was for some reason not an option to mow this site. They did not know really well what machine to use, and when they decided, oh yes, we have to mow it, it became really wet. So yes, it can be a problem, and it will reflect on the development of the vegetation in the coming years. So yes, why is it so hard? So yeah, maybe you don't have the right machine available to do this. It could be a problem to get rid of the vegetation. Where do you place it? Do you have a compost heap? Can you place it somewhere handy? And I would like to hear from you. Maybe you have other questions like, oh, how do I solve this? And how, I have no idea how to cut and remove this flower strip. Please share. So possible solutions in this could be to share machines. You're in the same area, close to each other, working with these flower strips. Or you could hire a local landscaping company who is very good at this type of work. Could be very handy. You can make a haystack on the production field or at the end of the flower strip. If this is allowed, I think that would be interesting to research. You can put some bushes around it, especially some willows, very good for bees in spring, and make a hotspot for biodiversity on your production fields. And then another question, how to deal with nutrient-rich soil. Because, you know, this can get weedy and grassy very quickly. I think I covered this already a little bit, but in general, one of the problems is there are not enough cuttings, and the production is so high that some dominant species will just take all the room there is, and you will lose some species. Is this really bad? I don't know. I think you should not expect so much from a very rich soil. What can help is to have an April cut. I also got this advice from Nikilde in Denmark, where they apply this sometimes, and it helps. But you can also try to avoid the very small species that are overgrown very quickly, and use robust plants that can stand this soil and thrive on it. A particularly nice subject fitting to this rich soil situation are orchards. I think some of you asked a question about this. What are proper plants for this? Usually orchards also have very nutrient-rich soils, very productive, which is good for your fruit trees. And here again, I think you should consider using very productive and strong plants, robust, that can stand some, well, I can give you a nice list of very suitable species. When we were working with this BEESPOKE project, one of the questions that we were asking, of course, was what is the importance of this species-rich mix for our goals? Do we need to have a narrow mix, or is it more beneficial to have a species-rich mix? And I think it depends on the situation, but it also depends, like Ivan said, what is your goal? Of course, we design mixes that are interesting for beneficial insects like pollinators, or are we also focused on the improvement of landscape for biodiversity? And I think these are questions you have to ask yourself before you design a mix. Like, for example, very important part of designing the mix is to consider local native seeds that are natural to your site. I'm just reading this so you can read it as well. Are attractive to a much larger group of species, including wild pollinators, not only for food, but also for reproduction. So, you know, it's a home, and it's food, and it's reproduction. It's your whole living environment that you're creating for all sorts of species. And the more species in the mix, the more different organisms it may attract and host. So I think, yes, for designing mixes, it could be very interesting, particularly for the enhancement of biodiversity, to consider this. And I think in all cases, tailor-made mixes can be a better fit. Sometimes you have standard mixes that are fine and will suit your crops, and perhaps also easily fit your landscape, the area where you are. But very often you are in a particular side of the country with particular plant species. And you always have to consider that you can have a better fit to organisms and the environment with a tailor-made mix. But yes, you have to tailor it, have to design it. And well, then there's also a question about what does this cost? Local native seed mix may be more expensive, for example, than an annual mix, of course. And this makes sense because annual species are so much more easy to produce. They give a lot of seeds because that is what they like to do. They only flower and seed one time and then they die, so they have to invest into these seeds. But yeah, you have to, I think, see a mix also as an investment and see how it will fit your landscape and how you can implement it for a very, very long time if this is possible. And then some people like to work with these annual mixes. Well, how do we feel about them? In general, I think they are less suitable for the enhancement of overall biodiversity because they may be good for some general pollinators, sorry, and some beneficial insects, so that's really good. But then you have to remember that you repeat it at the same site for a very long time because these populations of organisms depend on the availability of all these flowers. And like Ivan says, when you have a very poor flower poor area, every flower counts, and it's not very helpful to just plant a strip and then remove it the next year. So yes, a permanent site with flowers is always more useful. And when you want to use annuals, please don't use all these cultivated mixes with double flowers or flowers that actually are not very useful for pollinators at all. Like you can see here, these double corn flowers, they look very pretty and the color is extremely attractive to insects, but they don't give much. They don't have much to offer, it's sad to say. So be very critical about that. Okay, then I wanted to share with you this list of suitable suppliers for every country that we are working on. From Denmark, you can see here, and also from the UK, I received a list of addresses that are quite suitable. Oh, sorry, this is not what was happening. Yes, sorry. And this is from the Netherlands. I don't have to press a link. But from Belgium and Germany and Sweden and Norway, we still have to make this overview, and I can add them to the presentation when this presentation is shared someplace. You can check it all out. Please check out our leaflet on the website of BEESPOKE. It is very comprehensive and practical about the preparation and the sowing and the management of wildflower mixes in flower strips. So concluding to you, perhaps you have some other conclusions, but to make a flower strip successful, please pay attention to the right way of sowing and maintenance. And local native seeds are best suited to improve biodiversity locally. Very important, of course. So yes, do not sow just a random flower mix, but pick the right local native species that are suitable for a specific location and crop. I think this was my presentation. If you have questions.
Oh, thank you.
You want me to unshare or?
Yeah, it's nice to see some faces. Yeah, we will have the Q&A later on, but there was one remark from Michelle. Michelle, maybe you can share that with us.
Oh, it was just following on from the arable point about blowing the cuttings onto headlands or wherever with orchards. They can be blown into the tree row and act as a a double service as a bit of a mulch, and I think there's some work to show that it also increases earthworm activity in the soil, so benefits the soil as well. So I think it's about, I know a lot of our growers at the moment don't have the right equipment. In fact, even at East Morning, we haven't got a mow and blow machine, which I think is something we need to invest in to get the best out of our wildflower mixes, I think.
Yeah, thank you. No, I think on our production fields, we also have these rows with a plant. Just 2 years ago or 3 years ago, we planted some how you say, hedges, very rough with many species, very nice. And so bordering it are some flower strips, and we usually just rake all the cuttings from the flower strips into the hedge, and it is very happy about that so far. Because some bits of our production fields have very poor soil, so yeah, that needs improvement.
There's a question from Janet Allen. She's asking about what to do on ex-arable sites where you have a lot of grass weeds like blackgrass and wild oats that might be present in the seed bank, and they can be quite challenging when it comes to establishing wildflowers. So is there any tips for that? I was thinking of, ground preparation, of course, is key, and perhaps just spending a longer period doing that. But is there anything else you could do?
Yeah, you could definitely use a longer period doing that, because either that piece of land is suitable for grassland or something, and sometimes turning some bit of area that is very weedy into grassland can at least make you get rid of the weeds, depending on the seed bank, because some weeds have very long persistent seeds. So it should be useful for that. Like I said, with the dock, for example, the rumex, it can be very persistent, but especially if you let it sow, so you can already prevent things from going wrong by mowing it before it will start sowing. But yes, some especially annuals that are in your arable field that are a pain can be very hard to. If you don't want them to sow again, then I think it's not a good place for your flower strip.
Can I comment, please? Would that be okay?
Yeah.
Janet Allen here. Yeah. Well, the blackgrass is pretty widespread on some farms. I mean, all over England, but a lot of it in the southeast, and a lot of it germinates over winter. So my thoughts would be to allow it to germinate, in the late summer, early autumn, and then any grass that's already there to plough it as deeply as possible, so it's not, and then do cultivations and go for spring planting as giving you the most opportune chance to actually get it established. The other grass species we have big problems with, including in fruit orchards now growing in herbicide strips, is canary grass and millet, both of which germinate in May. So I think you've got to pray that you don't have both weed species on the same site, because that then knocks out your spring sowing. But I mean, we have some specific herbicides we can still use, particularly for things like the sort of millet and canary grass control, but blackgrass and now more recently wild oats are becoming a huge problem as overwinter germinators.
Oh, that's incredibly interesting. But I can imagine that, I mean, not for blackgrass, but I think that's also an annual, but it will germinate in autumn already?
Oh yes, it will germinate. It's germinating. Some of it's germinating now. And the normal practice is to leave fallows as late as possible and then spray it with Roundup, or and cultivate it in. I mean, I think they talk about quite deep cultivation with it to make sure it doesn't have a chance to come back up again, and that pushes the seed load down as well, because the seed is viable for quite some time. And when it's been building up for some years, and it's very difficult. The other possibility is to allow it to germinate and then to hit it hard with glyphosate as usually the chosen material, I'm afraid, because it still, in most cases, works, although there is some resistance now, in the spring, and then do your cultivations and drill quickly, so you get a nice growth of, and it's not really germinating in the late spring, early summer. It's really the overwinter is difficult.
Yeah,
But
exactly.
both horrible weeds.
Yeah. So, but could it be that for millet and canary grass, would be sufficient to do your sowing in late summer or autumn?
I think so. I think you get away with that but you would still get some problems, but you could probably top it. You know, in fact, I try to encourage growers anyway to top it rather than let it seed. So now you've got 1 million seeds rather than a couple of hundred per square meter.
Exactly.
But they are difficult. And of course, those millet and the canary grass are carried around by animals and machinery, etc. So you can shift them all around the site, as is black grass seed, of course, as well. So there we are. I just thought I'd fill you in with the wonders of growing things in England.
Yeah, I heard about black grass being a large problem.
Yeah, huge.
Had lunch.
Have you been on her at all?
Yes.
Okay, we're due for a quick break. Let's just make it quite short, quick comfort break. Start again in 1/2 So, and then we've got a fun interactive session, but also there's a reason for that, to get a little bit of feedback from yourselves about what you're up to, and then we've got the Q&A session at the end. Thank you.
So, John, do we have a 2-minute break, or when do we start again?
2 minutes? No, a bit longer. 5 minutes. Yeah.
Okay, see you in 5 minutes.